So today we're going to look at a little thought experiment to test your understanding of, I guess, mechanics for the most part. So I've done a little drawing here. On the bottom we've got a scales or a mass balance, digital mass balance, and let's say it's really accurate. And on top we've got a jar. So it's an empty jar with a screw top lid on it. And at the moment I've written in there, let's say it's a 75 grams. So that's fine. We've measured the mass of the jar. So my question is, or the question is, what happens if we take off the lid and a fly flies into the jar, and then we close the lid and put the mass balance back on the jar back on the mass balance? What do you manage now, or what do you measure now? So what's the answer? You can pause and think about it for a minute if you like. Okay, so let's imagine you've paused, you've thought about it, and your idea is, well, the fly isn't touching the surface of the mass balance, therefore, or he isn't touching the surface of the jar, therefore there's no increase in the mass measured. But it takes, I suppose, a little bit of thought and a little bit of lateral thinking. So if the fly wasn't actually flying and he was sitting on the floor of the jar, I don't think too many of you would argue that we wouldn't record his mass. So let's say the fly weighs 2 grams. You would assume that if the fly sits down on the floor of the jar, the mass balance would now read 77 grams. That's fair enough. So what has happened when it starts to fly? I mean, the mass hasn't gone away. It's still on top of the mass balance. So what's going to happen? Well, the truth is that we will measure the fly's mass on the mass balance at all times. So regardless of what happens, regardless of what the fly is doing, buzzing around inside the jar, if he sits down on the floor and we measure 77 grams, we'll continue to measure that 77 grams as he flies around. But how can that be the case? How can that mass be recorded as the fly, if the fly isn't sitting down on the floor? It doesn't necessarily make it doesn't make intuitive sense how that mass could be recorded if the fly is floating in air. I mean, what's the difference between the fly, at this point here and outside? Let's say he was sitting here. I mean, why should it matter in terms of measuring the mass whether the fly is here or here when he's up in the air in both cases? And the reason for that, or how we get to the bottom of solving that, is, let's do a zoom in. Okay, so let's imagine that this here is the bottom of our jar. So we'll draw it a bit bigger, and this here is our terribly drawn fly, and these are the 2 wings, so it doesn't look even remotely like a fly. But anyway, so each time the fly flaps his wings, what happens is he deflects air downwards. So the way the fly stays in the air is that he flaps his wings, the air goes downwards, and according to Newton's third law, the fly goes upwards. So all the time, if the fly is hovering in the air, he's constantly pushing air downwards. Those air molecules are bouncing off the floor, or the floor isn't the right word, but the base of the jar. So due to the fly's motion, there is a constant bombardment of air molecules hitting the bottom of the jar and causing a pressure on it, if you like, or causing a force on it. So there's a constant stream of air molecules bouncing down and bouncing off it. And the fly has to generate enough of a force to keep himself in the air. And to do that, he has to deflect his mass worth of air downwards in order to keep himself in the air. That mass gets deflected downwards, and ultimately the whole mass of the fly has to hit the floor of the jar in order for the fly to stay airborne. So regardless of where the fly is in the glass jar, he is effectively sitting on the floor of it, and his mass will be measured by the mass balance. So that's a tricky one, and another good one to test your understanding of mechanics. Now, that we can go a little bit further with this type of tricky problem, and this is kind of a famous one, and it's been done on TV shows like Mythbusters. I'm not going to go through this whole solution with you. I'm just going to sort of set this as a problem for you to solve yourself. So we need to set it up first. We need to draw what's going to be some water. So we've got some water. Let's take a different color, and we're going to draw our boat sitting in the water. So we've got a boat and we've got water, and this is a sailboat. So this is going to be the sail, and the sail looks something like that. Okay, let's make it a little bit bigger. So this is the sail, of our boat, and we'll colour it in like that. So what this question asks us is, so normally this boat would operate by the wind blows in this direction and blows the boat along. So what pushes the boat forwards is wind. Okay, so why can't we then, or maybe we can we, I suppose is the question, take a fan and attach it to the boat? So let's bolt a fan to the boat here. And okay, so this is our circular fan. This is the middle of it, and then we've got 3 fan blades. Again, bad drawing. Turn on the fan. Now we're blowing air towards the fan, or towards the sail, just the same way we would have been had the wind been blowing. So if there's no wind, right, we'll just turn on the fan. The fan will blow air at the sail and the boat will move forwards. So my question to you, or what you should go off and spend a bit of time researching, is, will this work? If it will work, or if it won't work, then why not? So what are the physics principles that might stop this from working if you think it won't work? And what are the physics principles that will make it work if you think it will work? And what you'll ultimately find out is that a real world situation like this is not that easy to analyze. So we can look at things in terms of the strict laws that we learn, like Newton's laws, conservation of momentum, that sort of thing. But a lot of the time they only apply in idealized situations. This is a real world situation where things are far from idealized, and the answer is there's no simple answer here. So it's something for you to go off and research, and the time that you'll spend thinking about it and the time that you'll spend figuring out why it will or won't or might work is time well spent, even though there is no simple answer. So go off and have a think about that one, and maybe do some more research online.